Following scientific progress these days, it can be a real grind, can't it?
Mm.
You see amazing work, but then it just vanishes into that peer review black box for ages. I saw somewhere the median is like 100 days in biomedicine.
Yeah, that sounds about right. It's a long time.
And then there's that, constant background worry. Is it reproducible? Is credit really going where it should?
Right.
And the frustration when, bam, another paywall locks away something crucial. Plus, you hear those whispers about, well, less reputable publishers.
Predatory journals, yeah. It's a real issue.
It really makes you wonder if there isn't a faster, maybe clearer way to share knowledge and build on it.
Absolutely. The established system, I mean, it's foundational, but it definitely has these bottlenecks, especially now, in our super connected world, which is exactly why these new approaches we're seeing using things like blockchains, preprints, and AI are sparking so much conversation.
Okay, let's unpack this then. Today, for our deep dive, we're really focusing on these three: blockchains, preprints, and AI, specifically in research.
Yep.
And the goal is to figure out how these techs are actually reshaping the scientific landscape and what the kind of key takeaways are for you, someone who wants to stay informed.
Exactly. Let's get past the buzzwords and see the practical side. So maybe start with blockchains.
Sounds good.
Okay, so imagine like a shared digital notebook. Everyone in a network has a copy, right? And every new thing added, every entry has to be agreed upon, and then it's permanently recorded.
By everyone.
By everyone involved. That's the core of this decentralized peer-to-peer network idea. And in blockchain, these entries, maybe research activities, get bundled into blocks.
Right, and each block gets that unique digital fingerprint, the hash, like an unbreakable seal almost.
Exactly.
And if you change anything, even tiny, the seal breaks and it's linked to the block before it. So you get this secure chain.
A cryptographically linked chain, yeah.
Yeah.
And these chains, these blockchains, they can be public for anyone to see.
Yeah.
Or private for just a specific group, or maybe something in between like a consortium.
Okay, so how does this actually connect to, like, research papers?
Yeah. Well, one really interesting use is for the manuscripts themselves. Imagine researchers putting their early findings, sort of like preprints, directly onto this secure, shared ledger.
So it gets time-stamped immediately.
Immediately, with a built-in record of when it was created and by whom.
And the peer review process, that could change quite a bit too, right?
Huge potential there. Instead of relying only on journal editors, the system could say, invite qualified scientists directly to review.
And I read something fascinating about reviewers potentially getting, like, rewards, tokens, through smart contracts.
Yes, that's a key idea. Using smart contracts, basically automated agreements written in code to handle rewards for reviewers.
So what's really exciting here is creating this totally transparent history, like a pedigree for every single paper.
That's the vision. A clear, unchangeable record, authors, reviewers. They could earn digital certificates stored in this ledger. It makes it super clear who did what and when.
And you could tie in things like ORCD, right? That unique researcher ID.
Exactly. ORCD integration ensures that contributions are permanently linked to the right person. Plus, you can use distributed file systems for safe, long-term storage of the actual papers or data.
And you mentioned code enforcing rules,
Yep.
like for peer review.
Right, those smart contracts again. They can automatically enforce rules, like specific criteria a review needs to meet before it's accepted or before a reward is issued.
Huh. So it feels like the power, the gatekeeping function is shifting away from just a few editors towards, well, the whole network.
Potentially, yes. If you're a qualified scientist and get invited, your review, your reputation, it all becomes part of this visible, permanent record.
Plus, every single step, submission, review round 1, revisions, review round 2, it all gets time-stamped on the blockchain. Creates an amazing audit trail.
Incredible, isn't it? That level of transparency and traceability. It could be a massive help for reproducibility concerns and maybe even for spotting misconduct earlier.
Are there companies actually building this stuff now?
Oh, yes. There are several players exploring this. Names like Artifact, Pluto, ScienceRoot, Eureka. They're definitely ones to keep an eye on.
And those smart contracts seem central to a lot of this.
They really are. Self-executing agreements. Think about funding, too. Imagine grants being automatically released when certain research milestones are verifiably met on the blockchain. More transparency there, too.
Okay, so zooming out, what are the really big potential wins here? What makes this approach so appealing?
Well, the potential to really democratize how research gets out there is huge. It could mean capturing research outputs much more directly, maybe encouraging more open data sharing.
And boosting the impact earlier.
Exactly. Making findings visible sooner. And that visibility, that traceability we talked about, could really help reduce things like publication bias or even fraud.
Okay, but it can't be all smooth sailing. There must be challenges, right? Bumps in the road.
Oh, absolutely. For sure. Scalability is one. Can blockchains handle the sheer volume of research data? Storage capacity is linked to that.
And how do you ensure reviewers are actually qualified and stop people from gaming the system?
Critical questions. Verifying reviewer quality, preventing manipulation. Those are big hurdles. Plus, actually creating and sharing these smart contracts isn't trivial, technically. And then there are the legal questions still being worked out.
Right, lots to figure out. Okay, let's pivot a bit and talk about preprints. We hear that term a lot more these days. What's the basic idea?
So a preprint is essentially an early version of a research paper. Authors share it publicly online before it goes through the formal journal peer review process.
The key being before review.
Exactly. And the main benefit is speed. Much, much faster dissemination of findings.
And that speed difference, it's dramatic, isn't it? We mentioned the 100 days for some journals. Preprints can be online in
A day or two, sometimes even faster. It's a massive difference.
wow. And that speed allows.
That means the latest research is out there almost instantly. It can spark quicker discussions, faster collaborations within the scientific community.
And they're citable, right? Even without formal publication.
Usually, yes. They typically get a DOI, a digital object identifier. So researchers can cite them in grant applications, talks, other papers, even before they might appear in a journal. And it's important to note, many preprints do eventually get peer-reviewed and published traditionally.
Okay, but if you're skipping that initial review step, aren't there worries about quality or, misinformation getting out there?
That's a really valid concern. It's probably the main counter-argument. Removing that first filter does raise questions about quality control and the potential for spreading inaccurate or preliminary findings too widely.
So how is that being handled?
Well, there's a need for really robust systems to manage the associated data ethically, and journals themselves are adapting. Many now have policies about preprints, sometimes integrating them, adding commentary, or facilitating review after the preprint appears.
Interesting how things are evolving. Our sources mention a specific example, the Meated World Initiative.
Ah, yes, Meated World. That started about, 10 years ago now. It's a platform for the medical education community.
To share what, exactly?
Ideas, innovations, practical experiences, research, more formally but also more quickly than traditional journals often allow. They can handle a lot of articles.
And they have specific features.
They do. For research articles reporting data, they have a required open data policy, which is quite forward-thinking. Authors suggest reviewers, but the platform invites others too. There's a big emphasis on the quality of the reviews, especially for research papers.
And the reviews themselves.
They get published, and they're citable with their own DOIs. Plus, articles aren't static. Authors can revise and update them over time. It's a neat model of a community driving its own knowledge sharing.
That really helps picture how preprints can work in practice. Okay, third piece of the puzzle, artificial intelligence, AI. How's that changing the game in research and publishing?
AI is bringing some incredibly powerful tools to the table for researchers.
Like what?
Well, accessing and analyzing just massive data sets way faster than any human could, performing literature reviews really quickly and comprehensively, even helping draft manuscripts.
Like a writing assistant.
Exactly. A highly efficient, often low-cost, time-saving research assistant. It can synthesize information and help structure the writing. And it goes beyond just writing. AI is starting to help with data analysis itself, even suggesting hypotheses.
So we've got these three strands, blockchains, preprints, AI. How do they stack up against the traditional journal model if we compare them on a few key things?
Yeah, doing a quick compare and contrast is useful. Well, let's take access, for instance.
Okay.
Traditional journals,
Yeah.
often restricted, behind paywalls.
Yeah.
Blockchain platforms, aiming for open, decentralized access. Preprints and AI-enhanced models.
Yeah.
Definitely focused on open and rapid sharing.
What about peer review?
Traditional.
Yeah.
Usually closed,
Yeah.
sometimes a bit opaque,
Yeah.
Blockchain. The idea is transparent review recorded permanently. Preprints, often open review or post-publication review, maybe AI-aided down the line.
And giving credit. Authorship.
Traditional systems, well, disputes can happen sometimes. Blockchain offers those immutable, time-stamped records. Preprints make attribution clear very early on.
Incentives for reviewers. That's always a tough one.
Yep. Traditional model. Pretty limited incentives. Blockchain, exploring those tokenized, automated rewards. Preprints. More about community recognition, reputation.
Speed. We touched on this.
Big difference. Traditional dot slow, blockchain opens for faster automation. Preprints, immediate sharing.
And barriers getting involved.
Traditional journals can have high barriers, cost-wise or otherwise. Blockchain and preprints aim for lower barriers, more automation. Although setting up and governing these new systems has its own set of hurdles for sure.
That side by side is really helpful. So looking forward then, what are the biggest obstacles stopping these new ways from just taking over? And where are things actually heading, do you think?
Well, there are some pretty significant general challenges. One is just cultural resistance or inertia in academia. Established ways of doing things are hard to change.
People stick with what they know.
Exactly.
Yeah.
Then there are the technical limits, scalability, making different systems work together smoothly, interoperability. Governance is a big one too. How do you ensure quality control in these decentralized
There's
systems?
the legal stuff.
Definitely. Legal and ethical considerations around copyright, data privacy, all of that is still evolving alongside the tech.
So it's probably not going to be one replacing the other entirely, more like a
That
mix.
seems like the most likely path forward, yeah.
Okay.
Convergence, maybe?
Yeah.
Coexistence.
Yeah.
We're already seeing hybrid models emerging, trying to blend the speed and openness of the new tech with the credibility and structure people value in traditional publishing.
Makes sense.
But getting it right, ensuring quality, good governance, ethical practices, that's going to take a lot of work, involving people from many different fields as these things keep developing.
Okay, so if we try to boil down this deep dive,
Yeah.
blockchains offer this potential for real transparency, maybe new ways to reward contributions. Preprints are speeding everything up, but we need to stay sharp about quality. And AI is just handing researchers these incredibly powerful efficiency tools. It seems pretty clear the whole landscape of sharing scientific knowledge is shifting significantly. Lots of potential, but also some serious hurdles still.
That sums it up nicely. And for you, the listener, these shifts are probably going to change how you find, access, and maybe even evaluate research in the coming years.
It really does make you think, though. In a world where information spreads so fast and through channels that are much more decentralized, what does that mean long-term for how we decide what scientific knowledge is actually valid, what's authoritative, what will trustworthy research even look like in that kind of ecosystem? Definitely something to mull over.